Okay, good morning. Welcome to DIT 2314 data structure. So today we will continue with topic number 2, linear data structure with arrays and string. Okay, so let's discuss about introduction to arrays. Okay, so the core definition of arrays, it is a collection of items that's stored at continuous memory location under a single identifier. Homogeneous elements is typically the stored elements of the exact data type of for predictable memory mapping. And we have the index-based access. This allow for a random access to any element instantly using its numerical index position. And we have the fixed size constraint. This is the traditional static array that require a predetermined fixed capacity upon creation. Okay, and then we have the one-dimensional arrays, the 1D arrays. It is actually a linear arrays, okay, and the element arranged in a single straight sequence from the first index to the last. And the one-dimensional array have zero-based indexing. The most programming language will start from counting array indicates from 0. It has a zero base indexing and have a memory allocation that occupies a previous block of RAM bytes determined by the data type's size multiplied by the length. And the traversals operation, it can easily scan sequentially by using simple loop structure like for a while loops. And then we have the second type of array, which is the two-dimensional or 2D arrays. It is actually a matrix structure. You have two data in a row and in a columns, and it resembling a spreadsheet of or a grid type. We have a dual indexing. It's required a two index value to pinpoint a specific element, for example like a row index and a column index. For the representation of memory, it uses a physical flattened memory into a linear memory block despite a logical grid representation. And it uses a nested loop, which is it process computationally using a nested loop structure for row by row iteration. Multi-dimensional array, instead of we are using one dimensional and two dimensional, we have a multi-dimensional type of array. It is considered as the high dimensional and is extend beyond two-dimensional and it more like a volumetric or a cubic-like data, 3D and beyond, 4D, 5D and so on. And it has a complex modeling that uses advanced spatial simulations with a multiple variable scientific computing and gaming coordinates. And it has an exponential memory growth. You need to have a quite large amount of memory block as it can, the dimension can be expanded and increased. And it uses address calculation complexity because it is a multi-layer type of multi-dimensional array, so you need to have the pointer arithmetic to compute the precise physical memory offset. Raw major order memory mapping. So we have a sequential storage rules. So these rules for the raw major order memory mapping. and it can store a multi-dimensional array row by row consecutively in this memory. And we use this primarily for adopting a programming language like C, C++, and Python. This is all the object-oriented type of programming, and using a address formula that able to calculate the memory location using the base address, the row size, and the column indicates. And the cache locality is able to optimize the performance of all the operation that able to scan the horizontally across rows sequentially. A column measure order memory mapping. So it has a sequentially storage rule with the storage elements for over multi-dimensional array across the column. One of the primary usage is we want to adapt a scientific computing language like Fortran, MATLAB, and R language. This is for a high advanced scientific formula computing language. The address is used to computes the physical memory offset that prioritizing the column movement before the shift rows. And the cache memory locality, it optimizes the performance for operation that scan the vertical down column. Array address calculation and arithmetic. So the base address principle for every array points to a starting physical memory address provided by the system. Offset multiplier index the value as a multiplier against the byte size of the stored data type. Constant time access, a direct formula evaluation grants 0-1 time complexity to looking up the element address. And the pointer relationship in language like C, for example, the array indicates the functions as constraint pointers pointing the first element. Basic array operation with the insertion and deletion. So this is the basic array. We want to insert insertion in a bottleneck situation. So the inserting an element in the middle requires a shifting subsequent element tracking from 0 and time. Deletion bottleneck, that removing an element requires shifting all following elements left to fill the gap. And operations appending or removing items at the very end of an array is much faster if capacity permits. And the capacity limits, we exceed a static array maximum capacity requires a manual resizing and memory allocation. Next, we move to the sparse matrix. So a sparse matrix is a matrix which the majority of its elements are 0 or lack meaningful data. And this become a storage inefficiency because we need to store every single 0 in a standard 2D array that wastes a valuable memory space. So our goal is to compress the memory footprint by storing only non-zero element, allowing with the coordinates. And we use this type of application in scientific application, in network routing, in finite element modeling, and as well as in machine learning metrics. And then we have this sparse matrix representation. Number one, we have the triplet form that able to coordinate the list that represent the matrix using a compact 3-column structure storing row, column, and value. We have the second type of sparse row, which is the compressed sparse row, CSR. This use an array to store a non-zero value, and we have a column indicates a row pointer to fast multiplication. And the third one is the compressed parse column, CSC. This organizes the data by columns rather than rows for the mathematical competition. And the link representation, that using a linked list to dynamically connect the non-zero element without the fixed size bound. Next, we have the string in computing. So instead of array, we have a string. A string is a sequence of characters treated as a single cohesive data unit rather than isolated data. And the character encoding will map the characters to binary numbers using a standard ASCII, UTF-8, and Unicode. It have an immutability concept, so some language like the Java and Python treat the string as immutable object, cannot be changed in place. On a storage point of view, it's stored in read-only memory segment or dynamic heap allocation. Memory representation of string. We represent the string by using a null terminated string. So in a C language style string with a null character, \0 or null to mark the boundaries. And with the length prefix string, we store the explicit length of the string at the beginning bytes for rapid bounce checking. And for dynamic bytes arrays, modern language like C++ and Python manage the string as a resizable bytes array behind clean abstraction. For buffer allocation, you require a careful buffering size to prevent memory overflow vulnerabilities during input processing. Now we move on to a basic string operation. We need to determine the length first, so we will calculate the total character count, traditionally achieved by scanning until the end and marker. And then we have to concentrate, joining the two separate strings together to form a single combined text sequence. Substring extraction, slicing a specific portion of a string based on a starting and ending indices. And comparison, lexicographically evaluating string alphabetically or checking for exact quantity. The string manipulation technique, we use a case conversion. We transform the character between uppercase and lowercase configuration, and then we're trimming and padding by removing the leading and trailing white space or filling characters with for alignment. Reversal, we will invert the character sequence order from back to front and use the tokenization. This is to split a large string into smaller substring based on a specific delimiter character. Move on to the basic pattern handling and searching. Substring searching by allocating the exact position where a smaller target string appear within a large text. And we have a naive algorithm that scan the text character by using a nested loop, checking every possible alignment. Exact matching, this is doing by verifying whether a specific password, keyword or identifiers exist inside a data set. And then we have a wildcard support that integrating a basic pattern matching logic using a placeholder symbol like asterisk or the question mark. What is advantage of using an array and a string? Number one, we have a high access speed that provides instant random access to element via direct index lookup in 0-1 time. And then memory locality, contiguous memory with layout maximize the CPU cache hit rates during sequential scan. Simplicity. The intuitive structure makes them easy to implement, understand, and debug across all programming language. Low overhead, the lack of pointers or metadata overhead per element, resulting in compact memory footprint. Limitation of arrays and string. Number one, it has a fixed allocation. With a static array, cannot grow or shrink dynamically once it initializes, risking overflow. Costly insertion and deletion. Shifting element in large array create severe performance bottleneck. Wasted space. There is pre-allocating maximum capacity for arrays that remain partly empty waste RAM. And we have a contiguous requirement with finding a single massive contiguous memory block for every large array can fail or fragmented system. Dynamic array as a solution. Why? Because the dynamic array can be resizable. Okay, the architecture is automatically, meaning it can automatically grow or shrinks into underlying storage capacity as element and ended or removed. Amortized analysis. So while the occasion resizing takes 0 and time, individual appends average out to 0,1 time complexity. And we have a growth factor that usually doubles its internal array capacity when full to minimize the frequent reallocation overhead. And then we have a language integration with power modern dynamic list found in Python, Java array list, and C++ vector. Now moving on to the real world application. So we use the array and string in tabular data, meaning that it can be used in spreadsheet, in database, and also in tables for software application. We also use array and string in image processing, that representing the pixel color matrix in digital photo and computer graphic. In text editing tools and software, we use the array and string in text buffer for document editors and command line, that argument parsing, and we use it for lookup buffer that serves as static configuration, parameters, routing tables, and fixed lookup dictionaries. Okay, so the summary and transition to next topic. So basically, the array and strings provide a fast random access but struggle with dynamic sizing and insertion. And we need to have a performance balance that understand the memory layout will help you to choose between a static array and dynamic alternative. And foundation for ADTs, it serves the underlying storage engine for implementing stack queues and hash table. And next topic, we will prepare the groundwork for exploring a dynamic pointer based structure like the linked list in topic number 2. Okay, thank you. We will see in the next topic.